Hello everyone, in this video I'm very glad and excited to introduce this new feature. That is how to implement the EtherNet IP, the adapter feature into Siemens S7-1200 or S7-1500 PLC. And this feature will allow the Siemens controller can run as an EtherNet IP adapter, basically the device. So any other Ethernet IP master can communicate with Siemens controller 1500 PLC or 1200 PLC. And regarding the Ethernet IP communication from Siemens feature, we discussed two videos before. And one video I discussed how can we run the Siemens controller 1500 or 1200 PLC run as Ethernet IP scanner, the master function. So any other Ethernet IP devices, for example, the Ethernet IP I/O, barcode reader, scanners, or any other Ethernet IP devices can communicate with Siemens. So Siemens controller can run as a master. Then you will ask how the Siemens controller can communicate with Allen-Bradley controller. Basically, we could have two methods. One method we discussed before. So in this case, the Siemens controller 1200 or 1500 PLC can use Ethernet IP CIP communicate with Allen-Bradley PLC. And Allen-Bradley PLC, the CPU, will run as a CIP server. And the Siemens side will run the CIP client. So in this case, the Allen-Bradley side do not need to program any special program, because the client side, they can directly type in the variable. For example, this start remote or start remote. That variable match with the Allen-Bradley side. So the CIP client can exchange data with the CIP server. The server side, this is the Allen-Bradley CPU, and client side, this is the Siemens PLC. Then you would ask, if this side, this is not Allen-Bradley CPU, this is other brand CPU, can Siemens CPU still communicate with those controller via the Ethernet IP communication? Or in another word, if this side, this is any other brands can run as an Ethernet IP master, can Siemens side can run as an Ethernet IP devices or adapter? Then we will discuss this case in this video. So Allen-Bradley side will run as an Ethernet IP scanner, the master, and the Siemens side will run as an Ethernet IP adapter, the device. So this is the third video we discuss the Ethernet IP feature from Siemens. And also this feature allows us to expand the communication very widely. That's because, as we know, the mainstream PLC or controller in industry world, that Allen-Bradley controller, Schneider Modicon M251 or Omron NJ-NX, these three main series controllers, they all support Ethernet IP master function. So in this case, if the Siemens can run as an Ethernet IP adapter or device, then the communication will be very easily, because set up the scanner and adapter communication, basically this is the hardware configuration wise. You do not need to program too much. Basically, the controller side import the EDS file from Siemens side and then set up the communication hardware configuration and download. Then the master and the device, the Ethernet IP communication will be set up. This will be very easily. This pave a way to exchange data across the brands very easily. Okay, in this video, I will use my test bench here, and I will use the Siemens S7-1200 PLC run as Ethernet IP adapter, the device. And I will use Allen-Bradley Compectlogic L32 ERM controller running as the master, the Ethernet IP scanner, the master. So let's go to the Siemens website and let me show how can we download this example, and I will show step by step how can we implement this feature. Let's go to support.industry.siemens.com, this application website, and let's search the ID number 109782-315. And we'll find this example. And this example, Ethernet IP adapter, the Ethernet IP device function, the Siemens controller can run as Ethernet IP device. Then you can download the documents and example project or the library. And in this case, I will download this library. And I like to specially show if you have one existing Ti Portal project, Probably you have some devices already connect the Siemens controller. And now your Siemens controller have to run as the Ethernet IP device. So this is exactly showing in this picture in my test bench. My Siemens controller 1200 PLC is communicating with ET200 SP. They are communicating via the PerfectNet. But now this controller will run as Ethernet IP device, and the Allen-Bradley Compectlogic will run as a master. So I have one existing Ti Portal project, and now I will add on this feature to this controller. So I will use this library. And currently I'm using Ti Portal version 17. So you can download the version associated with your Ti Portal version. Here, same as one typical Ethernet IP adapters, Siemens supply the EDS file, and we can download from here. Using this EDS file from the scanner master side, once we import this EDS file, the master and the device, they can set up the Ethernet IP communication very easily. For example, for the Allen-Bradley, Omron, Schneider Modicon, or even backup system, once you have an EDS file, you can import the EDS file and you can set up Ethernet IP communication very easily. So let's download the document, library, and the EDS file. And then let's shift to the Ti Portal side. I will do this procedure step by step. Alright, this is the Siemens Ti Portal system. And as you can see, in this existing project, I have the Siemens 1200 controller. And its IP address is 192.168.1.181. And it's communicating with ET200 SP. And this is the PerfectNet. And in this PerfectNet slave station, I have input and output. So its address is a 2 to 3, 2 bytes input, and also 2 bytes output. I have a 16-digit input and a 16-digit output. Okay, this specially demonstrates you have one existing project, and this CPU also communicating as the PerfectNet master. From this OB1, I have one very simple logic. This is basically doing the mapping. I'm using the MB byte to control the first byte of the output, and I'm using the MB200 to receive the input signal. And I download the program already if I click the on, so we can directly control the output. And also from this input, we can receive the status. For example, I'm connecting one button, and now if I click the button, I'm connecting the second channel. So once I click the on, so we will see the value shows 2. And now I'm going to implement the Ethernet IP adapter, the device function. So let's firstly go to the offline. And then let's go to the library. And from here, let's open global library. And then let's find out the library Ethernet adapter version 17, because I'm using Ti Portal version 17. Okay, let's open. But because the library, that's the compressed file, so default it shows nothing. Let's click this compressed library. Then we will see this and click the open. It will firstly unzip this library. So we will unzip the same folder at here. So after we unzip, in meantime, we also open this library. So we will see it import this LCCF underscore Ethernet adapter. And from this type, we will see Siemens provides S7-1200, 1500, and 1500 soft controller. So basically, the mainstream will use 1200 or 1500. So I'm gonna import this library. Okay, so let's drag this LCCF Ether adapter to the left side. I will drag to the program blocks. We will also see one date type LCCF type adapt diagnose. Okay, let's drag to the PLC date types. Okay, click OK. And then according to the manual, let's create a new organization block. That's a cyclic organization block. And in this case, I'm gonna use Allen-Bradley as a controller, as a master, to connect the Siemens S7-1200 PLC as an Ethernet IP adapter. The RPI time I will set 20 milliseconds. According to the manual, we better set the cyclic time to call this function need to be at least 2 times faster then the RPI. So let's select the organization block and select this cyclic interrupt. And here I will set this cyclic time to 10 milliseconds, at least 2 times faster than the RPI. Okay, and this cyclic interrupt I can rename 10 milliseconds. Click OK. In the OB1, I'm calling all other my regular program. And from this cyclic interrupt, I will call this function block 1. This is the EtherNet IP adapter feature. So from here, let me drag this IP1 to here. Okay, the system automatically pop up this and ask us to assign 1 instant dB for this IP. No problem. Okay, adapter dB. And from here, we need to assign something, especially for the input, output, and the config. So if you did any Ethernet IP communication before, you are very familiar with this. This is the buffer to receive the data from the master or send the data to the master. Also, this is a configuration buffer. So how can we define this? So we need to manually create 1 dB, and the dB will run as the buffer exchange the data with the master. So here we can click a new block and click this date block, and select the menu. I can assign the number. For example, I can assign the 10, and I will name this as dB underscore EIP. Okay, and here let's declare a date length for receiving the master data. So we will name that is the output, because as the master role, when the master sends the data to the device, this is the output from the master, right? So we will name outputs from master. And the date type, because our unit of this buffer, that's the bytes, so we can declare a certain length. I will use array. I will declare 128 length. So we will start from 0 to 127. And the unit length, that is a integer, SINT. Okay, we can write the comments here. This is the control data receive from master. Okay, and then let's declare the data buffer transfer from the device to the master. So we can call this is the inputs of the master. So inputs to master. And then we can use the same length, 128 bytes. So here, this is the input data to master. Okay. The third portion, this is a configuration. So we can declare config. Okay. And we can declare the same length as the master. So in the Siemens example, this length was declared as a 399 because the maximum length on this configuration, that's the 400 bytes. So from the Siemens example, it declared like this. But in the manual, it basically shows this length can defined as the same length as the output or input. After all, that 0 to 399, that take too long for the data block. That takes your room for your controller, right? So I will use the 128 bytes on the configuration for testing purpose. So this is the configuration from master. Okay, so we declare the length, the data buffer. Okay, we can assign those data to here. So output from master, we can assign to the output. And input to master, we can assign to the input. And config, okay, drag to here. So if we expand here, we will see the input assembling, output assembly, and the configuration assembly. So if you did the Ethernet IP communication before, those numbers should match with the assembly number setting from your controller side. But fortunately, we have the EDS file. If you open the Siemens EDS file, you will find these numbers in the EDS file internally. So that's why you basically do not need to touch them. You can leave as a shrink style. Those number has been assigned in the Siemens EDS file. Okay. And the enable we can assign one bool. Basically, we can leave always true. But in this case, for the testing purpose, I can assign one bool signal. For example, I can assign I'm 10.0. I can rename that as EIP enable. And then the interface. The interface, this allows us to assign the physical Ethernet port to use this function block. So if we go to the device hardware configuration, and let's go to the system constants. So we'll see, because this CPU has only one Ethernet port, we will use this Ethernet port to implement this function. So once we click this port, we will see this local number, this port number, that's the 64. Then we'll go back to the function block. We need to tell this function block, okay, which port we are going to use this function block to communicate. So we can click this drop-down list and we can select. If you have any other devices, you will see there are a lot of numbers at here. And you need to be very carefully, you need to select this local Profinet interface, okay? And this interface number, that's a 64, okay? We connect this. And then, this input, let's talk about the bytes, high and low bytes for represent one word. So to check this detail, you can open the menu. While we are at the Siemens website, this ID number, you can download the menu according to this example, right? So this is the input name. So you can switch this input true or false. So this basically swap the low and high bytes. So some system is doing some difference, especially if the Siemens controller need to communicate with one computer style system. So sometimes you need to select the true, but most of the cases we can use the false. If you find this high byte and a low byte to represent one word that backward, so you can flip this true or false. Okay, so we can leave this as the false. Okay, and the outputs here, well, we can monitor this DB, and while we are going online, we can see the output status, and we can use this status to diagnose, to monitor the status of this Ethernet IP communication. Okay, and now we configure everything. We can download this configuration and we can download the program. Okay. Before we download, let's quickly review a couple important settings here. So firstly, I'm using the cyclic interrupt 10 milliseconds. So suppose the RPI, the setting should be 2 times longer than this. Okay. And the Ethernet IP device buffer. The buffer now I'm setting 128 bytes. So from the Allen-Bradley side, we will set the 128 inputs and outputs. Okay, and the IP address of this controller, if we double click this port, we will see my Siemens controller, this is 192.168.1.181. And it's also running as a Profinet master controller to communicate with this Ethernet IP device. Okay, now I'm going to download. Okay, as we can see, to implement this feature for the 1200 PLC, we need to download stop all the controller. This you need to be very carefully. So if your system is running and you try to add on this feature, you have to find a chance to stop the controller and implement this feature. Okay, now let's start up. Let's shift to the Allen-Bradley side, the Ethernet IP master side, and let me show how can we import the EDS file. All right, this is the Allen-Bradley side. I'm using Studio 5000 version 32, and the CPU, I'm using Allen-Bradley Compectlogic's L30 ERM CPU, and this is the IP address of this CPU 1.191. And now let's install the EDS file at first. Go to Tools, EDS Hardware Installation Tool. Select Register an EDS file. This is as usual. Register a single file, or we can select Register a directory. Okay. Or we can select the register a directory. So we can register all the EDS file from Siemens side. Okay, I can select this folder. In this folder, it includes S7-1200 and S7-1500 PLC, their EDS files. Okay, and I select this look in subfolders. Okay, so it can search all. Okay, we can register all. Okay. Okay, we register 3 types of controllers. Okay, 1200, 1500, and i7-1505. This is a soft controller, so but basically we will mainly use 1200 and 1500 controller. Okay, finish. And after we register the EDS file, and then from the EtherNet area here, let's click this new module. Okay, we can search 1200. So we'll see SIMATIC 1200 controller, Siemens AG. Okay, let's click create. So here we will assign the name. Okay, assign this is the EIP S7-1200. Okay, we can assign this name. And the IP address, this IP address is 192.168.1.181. Okay, and other than here, so let's click this change. So default from this EDS file, a default value that's 64. Because I assigned 128, so I need to change this input and output to 128. This is something I like to specially try. If I'm communicating using 128 bytes, this is certain long. So basically it covers most of the application cases, right? So I can set 128. All right, click OK. Okay, click apply. All right, so again, we set 128, we set this IP address, and then let's go to set this RPI. Since the interruption, I'm setting 10 milliseconds. So this RPI times we need to set basically higher than 20 milliseconds. I can set 20 milliseconds for testing purpose. Okay. All right. Once we set up this, we can click OK. And we set up this station here. And in the meantime, if we go to the controller tags, we will see this EDS file project those input data and output data. Okay, this is the input data, and this is the output data. And in the meantime, we can watch this connection faulted if this is turned on. And once it's communicated successfully, so this faulted should show off. Okay, now let's download the Allen-Bradley controller. So my Allen-Bradley controller, the IP address is 1.191. Okay, let me download. Okay, download. So now the Allen-Bradley Compectlogic controller is running as an EtherNet IP scanner, the master. And the 1200 PLC is running as EtherNet IP device, the adapter. And the data length, I'm setting 128 bytes. Okay, now let's start up the controller. So now we will see here is showing this warning. That's because from the Siemens side, we haven't enabled the EtherNet IP device function block yet. So let's shift to the Ti Portal side. In the meantime, I can parallel these two screens, these two systems. So we'll see now it still have this triangle here, this warning. So that's because from the Siemens side, this function block, the EtherNet IP adapter, this enable we haven't enabled yet. So now let me enable. In the meantime, we can watch this I/O indicator from this Allen-Bradley controller. And once it finds the EtherNet IP adapter, this indicator should solid. Okay, let's enable. So as we can see, once I enable, basically after 1 or 2 seconds, this communication set up. And we will see this I/O indicator from this Allen-Bradley controller, it becomes solid. That means it found this device. And Siemens side, because this is software based, so Siemens side doesn't show any special. But Allen-Bradley side, this is the hardware configuration, right, for the master. So this indicator shows perfect now, all successfully. And now from this software side, we will see this adapter side is showing this update interval time is showing around 20 milliseconds. That status shows 7002. This is the correct status. And valid busy, they are true. Error, this is off. That means all the communication, they are correct. And now, if we go to the Allen-Bradley side, we'll see the triangle gun. If we double click this EDS file, this device, and we'll see it's showing running. Okay, that means communication is correct. And now let's verify the data communication. So if I go to this DataDB, and from this input to master, we can firstly set 1 byte value, monitor this DB. Okay, I can monitor this DB. I can set this input to master, the first byte, start from 0 to 5. And in the meantime, I can go to the last data, 128. The last data, actually, that's the 127, because that starts from the 0, right? So let me set to 100, for example. I will send this data. Okay, we set this two values, one from the very beginning, one from the end. And now go to the Allen-Bradley side, and this is the input data. And we'll see that index from 0, that's the 5. So it's receiving correctly. So now let's go to the very bottom, 127. So we'll see 127 received 100. That means we set 128 bytes. They are receiving correctly. And now from the Allen-Bradley side, let's send the data. So let's go to the output. Okay, in the meantime, I can open this output from master. So from this 0, the output, I can send 12. 12 is receiving correctly, and next one we can send 15. So we will see all those data can be received very quickly. Okay, and let's go to the bottom, 127. And in the meantime, let's go there, 127, this receiving buffer. So here, let's set 111, this decimal data. So we will see this 111, 111. Okay, and okay, 120. So we will see 120 here. They can receive very quickly. Okay, this is the 128 bytes buffer. And now let me do a very simple program. So as you know, in this system, I'm using the Siemens controller as a master to control the EtherNet IP device. So from the main program, I'm using this very simple program to receive the inputs from the ET200 SP. And also, I can control the ET200 SP output. Okay, now I can map in something. So from the Allen-Bradley side, we can even receiving the ET200 SP signal, or we can control the ET200 SP. So for example, in this case, I'm dragged to here. So as we can see here, this DO buffer is used to control the ET200 SP. And now if I use one move, now I can use this move the source that come from the EtherNet IP master, the Allen-Bradley, and then transfer to this MB100. Okay, so I can open this DB. Open this DB, and this is the buffer from the master, right? So if I go to the front, master 0, I can drag this master 0. That's the 1 byte, SINT, short integer, and transfer to this MB100, MB100. And then this MB100 will control the ET200 SP, the Q bytes too. This is ET200 SP DO. And this input, that source comes from the ET200 SP digital input. And it will transfer to the MB200. I will use another move. Move this MB200 will transfer to the buffer. The buffer, that's the input to the master, EtherNet IP master. So I will transfer to here. Let's drag to here. Okay, transfer to here. Then if I click the button, then from the Allen-Bradley side, we should see something. Meantime, from the Allen-Bradley side, if we try to control something, we can control this ET200 SP. This is the data flow. Okay, let's download. And let's turn on the monitor. In the meantime, I will move the camera towards to the ET200 SP and Allen-Bradley controller. And now, if I give a 5 to this value, so we will see this 5 received at the Siemens side, and this 5 sent to the ET200 SP. In the meantime, we will see this 1 is showing here. If I change this bytes to 127, so we will see all the output except the last one, they all on, right? If I change to 1, should be only the first output that turn on. So only first output that turn on. Let's go to the Allen-Bradley input buffer. And let's watch this input buffer here. So now I have this input button. So if I click this button, we will see the second channel here that turn on. So we will see the second channel turn on. In the meantime, we will see the Allen-Bradley side data will show 2 because this is the second input. And we can also see this input source come from the ET200 SP. And the ET200 SP data we copied to the MB200. And MB200 sent to this buffer. And this buffer will the EtherNet IP communication and send it to the Allen-Bradley side. So it's receiving this 2. Release, on. Release, on. So it's communicating very quick. It basically, there's no significant delay from my feeling. On, off. Okay? So this is input and output. So the Siemens master can communicate with multiple PerfectNet devices. In the meantime, the Siemens controller can run as the EtherNet IP slave, the adapter, so communicate with Allen-Bradley controller. The Allen-Bradley controller can run as a master to communicate with the Siemens controller. So all those data can communicate very flexible. There are also 4 valuable tests I would like to share. The first one, now we are communicating successfully and no any issues now. So if I go to the cyclic interrupt, if I click the online, okay, we can see the enable is true and the valid busy is all true. Okay, and now if I shut down the power on the controller side, for example, we stop the controller, basically we download the Allen-Bradley controller or even shut down the controller. So what will be at the slave side? So let's see the status. And now I can firstly stop this controller. So I will shift the Allen-Bradley controller to the programming mode. So from this video, we will see this Allen-Bradley controller is now running. Okay, this controller is now running. But from the Siemens, this EtherNet IP device is still showing okay. I guess this reason because this Siemens is communicating with Allen-Bradley, the EtherNet port, they are still communicating. Even the programming side is stopped, but hardware portion, they are still communicating. And now, if I shift to the run mode, we will see none of them changed. Okay, so this is test 1. We stop the Allen-Bradley controller. It costs nothing. But now I will shut down the power on the controller side, and we will see what will be at this device side. Okay, let's shut down the power for this Allen-Bradley. Okay, we shut down the Allen-Bradley controller power. So we will see my software is disconnecting with the controller. But the right side, the Siemens side, this violet shows off. Now let's power up the Allen-Bradley controller. So the Allen-Bradley controller needs a couple seconds to boot up. So now we can see after the Allen-Bradley controller boot up, and after a couple seconds, we saw this I/O indicator flickering couple seconds. And after that, we'll see the right side, this violet shows on. That communication automatically recovered. This is really great. Because once we configure the device, basically the device side will not be too many chances to reboot or shut down the power. But the controller side, we could download the controller, shut down the power, we may need to configure something. So this shows the case in case the controller, we need to download the controller or even shut down the power. Then once we boot up, so this device can automatically communicate, recover this communication. That's really great. Okay? So now we can go online. So this is test 2, shut down the power on the controller side. And test 3, I will shut down the power on the Siemens side. And here we will see this enable signal. Now this is the M address. And once we cycle power, this M address will go off. We can manually enable after it cycle power. So let's cycle power now. Okay, I shut down the power on the Siemens side. And after we shut down the power, we'll see this I/O indicator from the Allen-Bradley side, it shows blinking. That means it lost the communication. Okay, now let's boot up. And let's go online. Okay, after we cycle power, so this enable signal turns off. We can manually turn it on. And we can monitor again how long this communication can be recovered. Now let's turn it on. Turn on. 1, 2, 3. Okay, basically 2 or 3 seconds after, this communication can be returned. And we will see this I/O indicator from the Allen-Bradley side that turned to the solid. Okay, this communication recovered. So this is number 3. So after we cycle power, we can re-enable this communication. So this communication can be recovered very quickly. And now we will test the number 4. So number 4, it will show this case. If we turn on this communication, if we turn on this enable and the communication is correct now, and by some reason we try to disable this communication. Okay, let's try now. If I turn off this communication, so you will see this busy turns off. And Allen-Bradley controller cannot find this device anymore. If we go online, and we will see this warning show up. So this communication disconnect. And now if I turn on And let's see if this communication can be recovered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a special case, as we can see. If the communication is set up already, and by some reason we disabled this communication enable, and if you turn on again, this communication cannot be recovered. So this is the only issue now. So to solve this issue, the solution I will recommend is we will set this enable to true, or basically latch in this enable signal, unless you cycle power of the controller, and then you can enable again. But once you enable, do not turn off this enable after you turn it on. In this case, I can try this way. I will give always true to this enable, and let me download. Okay, and after I download, I can cycle power on this Siemens controller. And let's see after the cycle power if this communication can recover automatically. Okay, let me cycle power. Okay, I shut down the power on the Siemens side. And now let me enable the power. And we will see this communication actually recovered already. And if I go online, in the meantime, I can go to the top. We will see this connection faulted goes off. Okay, so this communication recovered by itself if we set true. So maybe set true would be a good idea, or you can give a command, and after the Siemens controller power up, controller start up, you can enable. But once you enable, do not disable that after the communication setup. Okay, give always true. Okay, we'll see this communication now is on. All right, this is the 4 scenarios I like to test. Basically, shut down the Allen-Bradley controller side or shut down the power on the device side. So we will see. This is the only case if we disable this on the way, it will cause the trouble. But once you give always true or prevent, turn off this enable signal, so this communication won't be a big issue. And other than this, I also highly recommend you review the manual. There are a couple pages I highly recommend you better review detailedly. EtherNet IP adapter for SIMATIC. Again, this manual can be downloaded from this web page, this ID number, and you can download this document. Okay, and in this document there are a couple pages I especially want to review. So the first one, you need to work carefully about your firmware of your CPU you are using. So for the 1200, the firmware you need to be above or equal to version 2.4. Basically, the new ordered Siemens controller, they all should be fine. For the 1500 PLC, their firmware need to be equal or above version 2.6. Okay, this is the firmware from the Siemens controller side. And then let's go to the PDF page 15. So here is showing the maximum size for the outputs and the inputs. According to the protocol of the Ethernet IP device, so basically the outputs and the input we should be less than 496 bytes. But frankly speaking, it's rare to see any device will use the data higher than 100 bytes. That's why in this case, I'm using 128 bytes for the testing purpose. So it's still communicating correctly. So I would say just to keep in mind that the maximum size for the output and the input do not exceed this maximum value size. And if you review the page 19 here is showing the maximum size of the 496 bytes is a limitation given by the protocol, the Ethernet protocol. Okay, and then let's go down, go to the page 42. So here, loss of the communication. You need to be very carefully because this function block is running as a software style. So it definitely take the execution time for the CPU. So you need to be very carefully on the CPU workload on the Siemens side. And also here, it is highly recommended to call the block at least twice faster than the RPI time. And in this case, the RPI time on the Allen-Bradley side, I set 20 milliseconds. That's why from the Siemens side, I'm using this cyclic 10 milliseconds calling this function block. Okay, this calling relationship, you must be very carefully. So if I go to here, this EDS file, and go to the connection, so Allen-Bradley side, this RPI time I set 20 milliseconds. Here we're calling 10 milliseconds, calling this function block. Okay. And from this interval output, we will see this time is showing here. Okay, this is cyclic time. And then let's go to the page 52, the risk of the overloading the controller. So keep in mind, this function block is not quite small. So for the 1200 and 1500 PLC, it's taking a certain high work memory and the load memory size. Also, it takes a certain time on the execution time. And now we can go to the Ti Portal side. Let's see what the actual size is taken from this controller. So we can go to the program info. As we can see, for this S7-1200 controller, its work memory that is 100K bytes. And the actual size, now this is very simple logic, right? So it actually taking 50K bytes. So it's using 50% of this CPU. Basically, this function will take 50K bytes for the work memory. The load memory, usually they are huge, so it won't be a big issue. But work memory, they are not expandable. So you need to be very carefully for this work memory size. In the meantime, we can watch the actual execution time. If we go to the online diagnostic, if we go to the right side, it won't take too long because we are using the interrupt. So we will watch this execution time. It roughly taking the 5 milliseconds around this execution time. So you need to be carefully. If some cases, some job, you have to use the very fast execution time. So this function block will take a higher execution time for this CPU. All right, again, I highly recommend you read the detail on this manual, and this manual also explains the procedure how to implement this function. So my video basically also follow this procedure, how to implement this function, the EtherNet IP adapter. As you can see, this is my test bench. In my test bench, I have Allen-Bradley CPU and the Siemens CPU. In the further test, I could use Omron or any other brands that controller can run as an Ethernet master. So see you in next coming videos. Thank you for watching.